Number Systems 8, Working with Scientific Notation. Today's learning target, I can both add and subtract two numbers written in scientific notation. So in learning target 1, we learned how to write in scientific notation. In learning target 2, we're going to learn how to add and subtract. So the first one we're going to look at is how are we going to add two numbers? So as I talk here, make sure you're listing the steps in which makes sense to you that I solve the two examples for. So again, we're going to find the sum first, which again means addition. So we'll get started with a problem here and walk through the steps. So the first problem we're going to look at is 8 and 12 hundredths times 10 to the 7th. And we're going to add that to 6 and 13 hundredths times 10 to the 7th. So a couple things I want you to notice. The first thing that I do, my first step would be, is that I need to adjust my mantissa until both exponents are the same value. Well, in this case, we're going to look at both exponents here. I have a 7 and I have a 7, which means they're already in both the same value. So I don't have to adjust the mantissa. But if they weren't, my first verb, my first step would be to adjust. And next thing we'd do, second step, is that we add the mantissas together. So we have 8.12, and we're going to add that to 6.13. So notice that it's just going to be addition here. So if I add 8.12 plus 6.13, I'm going to get the total, or the sum, of 14 and 25 hundredths. And then what you do is you just bring down the exponent and its base of 10. Since they're the same, you just bring those on down. I'm going to write it here first. So we add the mantissas, bring down the base of 10 with its exponent, bring that base of 10 down with its exponent, and we have, at this point, added the two together. Now, my last step is, the verb is to make sure your answer is in the correct scientific notation. So if I look at this right now, my mantissa is not between 1 and 10. So I am going to have to move my decimal 1 over. So it becomes 1 and 425 thousandths. That mantissa is now in correct scientific notation. Now the deal is, though, when you move it to the right, which means I go one more place value, or I have to multiply it times one more 10, that means I'm going to add 1 to my exponent, which now makes my base of 10 to the 8th power. So my final answer is this last one here, 1 and 425 thousandths times 10 to the 8th. Let's look at example number 2. So I have 9 and 42 hundredths times 10 to the negative 5th. I'm going to add that to 7 and 32 hundredths times 10 to the negative 6. So step number 1, reminder, adjust is my verb, the mantissa until both exponents are the same value. Well, if I look at this, I have negative 5th and I have the negative 6, and those are not the same value. So I have to adjust one of these mantissas. In other words, change one of these mantissas so they're the same. I always go to the bigger one. So negative 5 is bigger than negative 6. So I'm going to adjust this mantissa to become 10 to the negative 5th, which means I'm going to have to multiply it times 10 to the negative first one less time because I'm going bigger, which then means I'm going to move the decimal to the right. You've noticed I've done that twice now, moved it to the right, and I'm always adding 1 to the exponent when I'm moving to the right. So now I have 0.732. I'm still going to add that to 9 and 42 hundredths. And now I can actually add the mantissas because my exponents are the same. So we'll go ahead and add the mantissas. So 9 and 42 hundredths. We're going to add that to 732 thousandths. And remember, you just bring down your base of 10. So now it's to the 5th power. So when I add those together, I get 10 and 152 thousandths times 10 to the negative fifth. But notice that again, I got to look. My last step is always make sure your answer is in correct scientific notation. It is not, because this is more than 10. So I'm going to move it to the right 1. And that means I have to me, it makes sense that if I move it to the right, I have to multiply it times 10 one more time, which in this case is going to be adding 1. Notice I've done that 3 times now, added 1 when I moved it to the right. And so it becomes 1.0152 times 10 to the negative fourth. And that is my final answer. All right, let's jump into finding the difference. So again, listen to my steps as I talk here, and you can write them down as it makes sense to you. I usually have 4 steps, and they're very similar to what we just did with addition. So this time we're going to describe how to find the difference or how to subtract. So my first example is going to be 4 2/10 times 10 to the ninth. I'm going to subtract that from 3 8/10 times 10 to the ninth. Step number 1, the first thing I always look for is, do I need to adjust the mantisses so my exponents are the same value? So if I look, oh, they're both 9s. I don't have to adjust anything. I can now go ahead and subtract my mantisses. So I subtract my mantisses, and again, you just bring down that base of 10 with the exponent since the exponents are now the same. So it's going to be times 10 to the ninth. And so then I'm going to subtract. So 4 2/10 minus 3 8/10 makes 0/10. Or I'm sorry, 4/10 times 10 to the ninth. So I subtracted my mantisses, got 4/10, brought down my base of 10 with that same exponent. My last step, the most important step, is to see if it's in correct scientific notation. I look, oops, it's not, because it has to be 1 or greater or less than 10. It's 0.4, which is not greater than 1. So I'm going to move the decimal over to the left. So I moved it to the left. So it becomes 4 times 10. And when I move it to the left, I'm going to actually subtract 1. So it's going to be to the 8th power. Okay, new example. Let's subtract 6 9/10 times 10 to the negative second minus 6 times 10 to the negative third. Okay, let's go through our steps. Just the same as when we add, we're going to see if my exponents are the same. If not, I have to adjust my mantissa. So I have -2, -3, not the same. Again, I always go to the bigger one, so I'm going to adjust this -3 up to +2. So I want this to become +2, which means I'm going to add 1. So I don't touch the first scientific notation. I'm still subtracting. Notice that right now, that decimal's, I don't know how that got there, but decimal's right here. I want it to go to the right because I'm going to add 1. Okay, so if I go to the right, that becomes 0.6 times 10 to the negative second. Now we're good to subtract since the exponents are the same. So I'm going to take 6 9/10 minus 0.6. And I'm just going to bring down my base of 10. And I'm going to actually subtract. And that becomes 6 3/10 times 10 to the negative second. Ooh. And I got to check if it's in correct scientific notation. It's between 1 and 10. Looks great. And I know that I am done with my problem.